Hey everybody, this is Larry. This is me going over the daily problem for July 28th or 29th, I guess. But I'm doing it on the 28th, 808 soup servings. So actually, as you can see, I already kind of solved this problem a little bit. This video was kind of long, so I just want to give you an intro before you actually see the live portion of it. You're seeing the live portion of it next, so definitely feel free to kind of skip forward, skip ahead. In the first couple of minutes, the first 5 to 10 minutes or so, I'm going over some of the strategies and thinkings and thought process. But I did get a little bit stuck, so definitely skip ahead the middle chunk a little bit, and then I realized what I needed to do. So definitely at the end, I kind of go over, like the last few minutes, I go over the entire process and what I think about it. So definitely check that out. So don't be intimidated by a very long video. You know how to do fast forward, you know how to skip ahead, you know how to press some buttons. Technology is great. I believe in you. Y'all are smart. That's all I have. So watch the video now. Hey everybody, this is Larry. This is day 29 of the Leetcode Daily Challenge, and looks like we'll have a weekly challenge as well. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. 808 soup servings. We haven't done this one before, but it has a lot of downvotes. You know, I usually don't notice it, but I don't know. I did notice it today. So yeah, I hope everyone's having a great weekends here. Hope everyone's just having fun. And yeah, let's take a look at this soup situation. Okay, so there are two types of soup, A and B. You have n milliliter of each type of soup. There are 4 kinds of operations. Okay, so basically some percentage of like, right. Oh, you can't do 0% of A and 100% of B. Yeah, and they even tell you in a note. But other than that, I guess in increments of 25%. We may serve some soup, okay. We will choose one of the 4 operations with 25% probability. The remaining will serve as much as possible. We stop once we have no longer have some quality of both types of soup. Okay, I mean, it's a very awkward phrasing, but okay. Return the probability that A will be empty first, plus half the probability A and B will be empty at the same time. Okay, so kind of like an expected value in a weird way, but okay, fine. There is some error margin expecting that the answer will be a float or a double or whatever your language allows. Okay, so I mean, I think this is just straight up recursion. Unless I missed, what is N again? Oh, we have 50 milliliters of A and 50 liters of B. And we just have all these things, and 10 to the 9. Okay, I guess that was going to be the next thing I look at, is that given 10 to the 9, so if n was small enough, you can just do regular brute force dynamic programming, just recursion, right? As of right now, it's hard to say. Off my head, I don't know that I have anything. I think if there was that operation where B can be used, I think by symmetry it would just be 50-50, right? But okay, I mean, I think even if you divide this, so the other thing is to simplify it a little bit, is that you can divide everything by 25, but of course even 10 to the 9 over 25 is still too big to kind of do one at a time, right? That said, I think these kind of problems, I mean, I don't know, maybe some people are very good at math and they're kind of able to figure it out very quickly. I think, but one thing that I would recommend doing in general, and I might do this, but I'm trying to think through a little bit on some implications that are in my head. I haven't done this before, but I also don't know this one yet, because this is kind of a novel, awkward one, one that you may see more in Code Force, perhaps. But yeah, one thing that I would recommend is that even though you know that this will time out for big ends, write the brute force, write the DP, see if you can kind of see the pattern from n is equal to 1, n is equal to 2, ... right? But I'm trying to think. I think one thing that you can I mean, there is some like binomial-y thing about this. That's what I'm trying to figure out, right? So it's kind of awkward to do though. Like I'm trying to think about at the very least, you know, right now if you kind of write the brute force one, you might have something like A and B, right? And you know, these have two states or two dimensions, right? I think one thing that I've been trying to think about right now, and I don't know the answer yet, is trying to think whether I can reduce that to one dimension. But I'm not quite sure that I can. To be honest. And I think like I recommended doing dynamic programming and playing around with small examples. But I think one thing that we can also maybe think about as well is build from it backwards, right? You know, start from 0, 0 or whatever, and then 0, and then also maybe build up that way. And I might have to do it. I'm trying to think whether I can think my way out of this a little bit. Maybe I'm missing some obvious observation for now, but that's basically my ideas. Let's start with some basic numbers, right? So, yeah, first of all, we divide everything by 25 because everything just, you know, it rounds down anyway, I think, right? It doesn't really affect anything. But let's say we have n is equal to 25. I mean, we can also just write the code for this to figure it out. But I'm trying to figure out just in general. In this case, what happens? 100% of the time, maybe? No. Oh, basically B. So A wins, or sorry, B wins if and only if this. So B is equal to 25% of the time. A is, and then the rest of the way, B at least tied. Oh, sorry, I think I said this wrong. I think A wins 25% of the time, and then the rest of the time, let's just call it AB is equal to 75%. So half of that is going to be 38 or whatever, 37.5, right? Did I do this wrong? Because apparently that's the same. That's the answer for 60. So, because every other case is just at the same time, right? Did I do something wrong? That's 6. Because Let's try n is equal to 50 then, right? Well, if n is equal to 50, then A wins half the time. And then the rest of the time, well, in this case, only this case, right? So that's actually 25%, half of that, so 12.5%. And then B just wins straight out for the rest of it. So, wow, so that's kind of interesting, right? I mean, maybe that's just like base case things, but it is the same for n is equal to 25 and n is equal to 50. And these are, you know, the small cases are easier because there's only one iteration, right? You get the answer no matter what. Is that the case if n is equal to 75? Well, A is equal to basically these two, so 50%, right? B is equal to 25%. And then here there's 25% of going into f of 25, so which is going to be 62.5. So just, you know, I think we can just times this. But maybe I'm wrong because of no, I think this is right. Is because probability the way that these things are is linear, right? So what's that? Times 25, so that's like 15.6%. I mean, I rounded Okay, fine. Here's it, not rounded. Right, so that's 65.625% or something. Is that right? Yeah. Does this tell me anything? I don't even know. I don't know that I see anything yet, to be honest. And I don't really want to, you know, go all the way through. How is this a medium? Wow, maybe I am missing some. I mean, in the dynamic, the DP seems pretty straightforward, but yeah, and even if you do some optimization, there's still not enough. 10 to the 9th, huh? I mean, I imagine some of it converges, but this is kind of funky, right? If n is equal to 100, all right. All right, in this case, let's do it. Let's just write the brute force thing, and then we'll figure it out. And this is already divided by 25, let's just say, so we could keep it lazy. And then basically we have if a is equal and b is equal to 0, return 0.5. If a is equal to 0, return 1.0. If b is equal to 0, return 0.0. Otherwise, we return calc of a minus 4. I guess I should make this whatever, just to be easy. B plus right? And that would be really, oh, I don't know why I had commas. That would be pretty much it, but divided by 4, right? Yep. But now we can kind of play around with you know, just going over some small examples, right? But we can also see that if we have like we might run out the time limit, right? Okay. In fact, a lot of recursions. I mean, even if you don't do the recursive one, because you can probably reduce this to just using A and stuff like this, but because in total, is that true? I don't know. I don't know. Maybe not, but even then, it is still like if you just do a for loop bottoms up, it's still pretty bad. Let's see if we can. Is there a way I can show the? So whoops. I feel like in the past this is much easier because then you get to what the. Did I mess something up? I guess so. It resetted my test cases. It used to be that it just shows all the answers at the same place and stuff. Like now I have to kind of click through everything. But okay, fine. Okay. Right, so 62, 62, 5, 65. So we were right on our math, I deleted it. 71, 875, 74, 75, 78. So it goes up, but not like in any recognizable to me pattern. This is gonna be a long day, isn't it? Yeah, I'm trying to, it feels a little bit, Let me think of another way to write this, right? Because you can kind of change this a little bit, but I don't know that that actually makes it tractable. It does make it a little bit like I don't know if that's true. I'm trying to also still. I mean, this is nice to kind of get a visualization, and even if it converges on something, it doesn't matter for me in the sense that you know, it still doesn't give me the answer quite, and this may already be too much. So now it's 80 things, but I'm trying to think, is there a way to reduce the state? But even reducing the state into one dimension is probably not enough. We have to figure out a way to actually well, maybe I don't know how to do this per se. Maybe we can try to figure about how to. I was going to say how to get them so that A and B are at 0 at the same time, and then maybe we can figure that out. But I don't know that that's good enough either. Oh, and n could be 0, which is, I guess, an input, but what a silly input. Did I put 0? Yeah, I mean, guess that counts 50-50? I guess they're just tied, right? So it's 100% of half. I mean, we can rewrite this as A and the sum, but I don't know that that helps that much. It's still 2 dimensions that depend on each other. I'm trying to figure out, is there a way to kind of reduce this almost like in Fibonacci, but that's the thing that was, and then you could do like repeat doubling or something, but that feels ridiculous. Using like the Q matrix or something. I really don't have any idea, to be frank, right now. But let's kind of, maybe that's why there's so many downloads. Though I don't. Maybe I'll, I don't really download anything. But we have ever downloaded something. I think okay. So this obviously didn't really help us that much with calculating this. But one thing that we can do is actually just visualize the matrix a little bit more as well. So let's play around with that. Let's just cache this real quick. Print ij calc ij, and then here we can actually just remove all these things because we don't need. I just do 200. What? Oh, whoops. That makes sense. 1 1 is 625. 1 2. 2 is 0. Now because of pigeonhole. Can I get this if I just get like here? 3 0, 3 1, 3 3 3 2 is 0.5. 2 1 is 0.5. I don't know that that's a pattern. Yeah, not really. Yeah, I still don't really see anything, obviously. Because if I did, I'd be like, up. I'm trying to think if there's something that we can use knowing that this is the thing that's taken out. Because otherwise it is always just 50%. But now it's skewed toward A. But how much so? Is there anything we can do with repeat doubling? We can't even do a simulation here, so oh, excuse me. Basically, this gives us an insight into the matrix. Not like in the movie, but like, try to see 2 3 and 3 2, and then see how that kind of relates, maybe. Because right now we're not seeing it in the matrix as much, but I don't see any pattern or anything to me. But it's not, I just don't see it. Even if there might be a bit. And then at some point it is just some like pigeonhole thing that gets it to 100%, which makes sense because you always remove 1. I'm still trying to figure out like whether you can remove a dimension. It feels like there is something that you can do about that, but I am not finding it. Wow, there's a medium. I guess there must be some gotcha or something, but would this be easier if I represent these as fraction? There's 1/2, 5/8, 6/8. The 2 will always be 8, but I don't know. 10 to the 9, huh? I don't know how to do like doubling. These are all the states. I don't really see anything obvious. Let's try like, maybe I'll do a little bit more just to see. A lot of ones, but I mean, as you can see, it converges very quickly, which is kind of what we expect, right? But that doesn't mean, you know, we have to be precise enough to get it right. So let's say we start at 0, 0, right? Then we can branch out. 0, 0 is a 0.5, but then now that means that 1, 3. Huh. Well, today I have met my match. First. Well, what is the expected value, right? So the expectation is that we have on the left side, on the A side, we have -1, -2, -3, -4. So the average, that's -2.5. And then on the B side, we have -0, -1, -2, -3. So that's -2 on average. Does that tell us anything? That means that the break-even is going to be like 5 and 4, maybe. Is that even true? Let's see. What's 5, 4? 5, 4. It's a little bit higher because we have to figure out how to do the ties. And then like 10, 8 maybe would be the same number, maybe. I don't know that that means anything there. No, it's a little bit different, but a little bit higher even. Huh. I think is that it? I mean, one thing that you can do is create a ridiculous set of linear equation, and then and then do repeated doubling. But I feel like that's a ridiculous solution, right? Like, I feel like that's not the easiest solution to go. Like, we can definitely do it. It'll be can we even do it easily? I don't even know if we can do it easily, but man, this is just one of those days, I guess. There really is nothing else to say, right? Oops. Like I'm trying to see if I'm missing something obvious, but I mean, we got the right answer using this. It's just that this would never be fast enough. Yeah, I don't know. I'm not good enough at math at this. Well, actually, maybe I lie. Maybe we can simulate to see where it goes. Because I think that's kind of. I think I'm used to the fact that 10 to the negative 5 is usually a what can we call it? A relative error, but this is an actual error, right? So that means that in theory, we just need to calculate enough such that okay, so maybe we do something like whatever, right? I is equal to 0 while calculate I minus calculated I minus 1 while this is greater than 10 or 1u negative 5. Let's just say even greater than this, then right? Maybe something like this. And then we can kind of see how far this goes. Where did I maybe this starts at 1, right? Because I think that is just silly. 1 1 1 0 0 0 0 shouldn't this keep going a little bit? Did I mess up? Alright, let's just try this. Did I mess up? Could he messed up? Okay. Did I mess something up? That should be right? Oh, in this case, it is actually literal 0. Okay, fine. That's the one case where it is not. Okay, fine. Let's go up to 3, say. Right? And then now it goes up to 154, right? So that means that after 154, the delta and change, and maybe we'll go up a little bit higher, right? Just in case there was some like weirdness like the other one where everything is very close. So maybe we do something like 200, right? Actually, and I'm actually wrong here now that I think about it. Actually, what we care about isn't what we care about isn't this delta. It's actually 1 minus this, right? So because we know that it's going to converge to 100%. So that means that, so while 1 minus or just I, so while this is greater than 1u negative 6, then we can print this thing. So maybe that's a better termination point. I mean, effectively, it's going to be the same. I feel like 200 is good enough. And in fact, maybe I lied. it goes up. Well, this is because I do 1G's -6 and not -5. So this is a little bit even more safer. But that means that we only have to calculate up to 222. Let's put this 0 for now. I mean, I was actually trying to solve the problem because I think that actually may be an interesting problem. But if this is the solution, maybe that's why the downvotes. And because everything that's bigger than this, you can actually, reflect. I mean, and you could like add you could add more numbers just to kind of, and there's 222 times 25, but yeah, but everything after that you could do like 100% or 1, and that'll be good enough because that's within, there's no number that's in between because they're just small enough, right? So maybe we can do something like right. Oh, this is for 0. I have to run this locally, don't I? I just wanted to pre-calculate this, but give me a second. I'm gonna run this locally so that I could paste this in. You see the code, so I'm not doing anything too fancy. I mean, I'm still trying to find like a quote-unquote more beautiful solution, but for now, maybe I'll settle for solving it and then we'll figure it out. Give me a second. You can't see it on the screen, but I'm just running it locally. What am I doing? s.subservings. Doesn't matter because that's not. Where's cache? Func tools. Tools import cache. All right. So then basically this gives us, and now we can do it. Now we have, is this just, okay, yeah. Yeah, and then basically, as we said, so n to do 25, if n is less than length of array, then we return of n, otherwise we return 1.0, right? We reset the test cases, so 1000 works. And anything that bigger than that, it just goes to 100% anyway, so it's not even worth testing. I mean, it could be just wrong, but yeah, and then now we can give a submit. Oh, snap, did I mess up? N is equal to 1. Is that, oh, do we want to round up? I made a silly mistake in understanding, because I assumed I wanted to round down, but clearly I'm wrong here. Did I want it to round up? I guess so. I was worried about the other parts that I didn't really think about this part, so yeah, anyway. Right. And I put up random stuff too, so okay, 1, 26, 28, 55, 2, whatever, okay. But it worked for the other ones, I don't know. Alright, so that looks good. Why are you telling me about inconsistent results? Alright, there we go. 12-15 day streak, but I'm really not happy about this particular one, obviously. Alright, let's see if we can learn something. That's kind of cute though, but so we're going to seal 25. I kind of messed it up because I was focused on the other things. Yeah, bottoms up DP. Yeah, okay, that's basically what we eventually got. But I was kind of trying to figure out something more nicer, but because I think I actually did notice this early on, but I didn't really. I kind of looked at it and then kind of put it out of mind. And what I mean by this is is this line, right? Because it's actually 10 to the negative 5 of the actual answer. What actually happens a lot in Codeforce, and maybe I'm wrong on this because it's been a while, or Top Coder or whatever, is that they allow for answers that are within 10 to the negative 5, but it's a relative error, right? Meaning that it is like some percentage of the answer and not absolute value. So it's a little bit awkward, and maybe I think that's why I kind of maybe conditioned to do it in a way. But otherwise, this was pretty straightforward, and I guess that is the trick. Yeah, okay. I mean, I knew that was the case, but I was hoping that there's maybe I was hoping that there's a beautiful solution and I didn't have to do it this way. But yeah, I mean, it is a fun problem, but also terrible problems for the interviews. I agree with that statement. It seems kind of cheesy, and obviously you don't actually need to do it like this. But and we actually did write the code, right? And we got it in like 5 minutes. But yeah, I guess it is what it is. I don't really have much to say about this one. I would say some of this is I'm out of practice about this. This kind of problem, this kind of thing about noticing constraints do come up a little bit on Codeforces and competitive programming. You have to kind of, in a way, you have these I want to say calculated constraints. I don't know if that's I'm not in the game, so to speak, to know all the technical terms that people use in competitive anymore. But like a sort of like a calculated constraints, right? Constraints that are implied but not given to you. And this comes up in competitive a lot. Sometimes like very often, some of them are relating to like the number of bits or something like that. I think that's a very common one. Some kind of like pigeonhole-y things that forcing functions that are kind of force certain things, and if you kind of do brute force but only up to that forcing function, then you'll be fine or something like that. So it is definitely fair game for competitive, but definitely for interviews, I don't imagine so. They say it's from Google or whatever, but I don't know. I guess of all the places, I guess Google would be the ones to ask these kind of silly questions. But in general, I think people want to see how you think, and I don't know. And this is also one of those things that you give a minor hint and everything's gone, right? Because I think you just put a minor emphasis on this line, but I think I was just too stubborn on this problem, and that I thought that I wanted to do something. Like I thought I was just trying to do something clever. Like maybe I missed something with DP and repeated doubling or something, right? But I couldn't really reduce the state, even though it feels like you could, but I couldn't do it. Yeah. Anyway, here's the code. I mean, if you wonder how this generated from, I literally just ran this code. I mean, I ran it locally because the console didn't allow me to print out. Like it gets chopped off somewhere. But otherwise, I literally print this and I dump it in here. And then I did, the rounding up, the ceiling thing. And that's it. Though I did get a wrong answer because I was so, I guess maybe I'm tilted a little bit by the fact that this problem is a little silly, that I was like, let me just submit this. It cannot be right? But as well. Anyway, that's all I have for this one. Let me know what you think. Yeah, and here I think you can maybe do -5, but I just wanted to be safe. That's why I did it that way. I think, in case you're wondering. But yeah. That's all I have for this one. Let me know what you think. Have a great weekend. I still got to do the premium problem next. So definitely, yeah, stay good, stay healthy, take good mental health. I'll see y'all later. Take care. Bye-bye.